To find the probability of x equal to 5 using the CDF, so what you can do is just exactly equal to 5 would be, you have the formula here, probability of x less than or equal to 5 minus probability of x less than or equal to 4. So using that formula, equal to less than or equal to 5 minus less than or equal to 4. Oh, sorry, the location is wrong. So it should be using the CDF, that will be the yellow region. So change into the yellow region and you will get 0.0378, the same as if you using the PMF. Now, go to the next question, that will be find the probability of x less than 5. Less than 5, we are using the PMF. So less than 5 would be, okay, equal to, you are looking for the answer less than 5 using the PMF, so it would be from 0 until 4 because 5 is not included. So definitely equal to sum 0 until 4. So you will get 0.0293. If you are using the CDF, okay, so you are looking for less than 5. So it means that since 5 is not included, so definitely it will be probability of x less than or equal to 4. So look for CDF less than or equal to 4. Okay, you will get the same answer. So for less than or equal to 5, now you are talking about 0 until 5. Okay, so it will be sum from 0 until 5. And using the CDF, definitely you just go to the cell where less than or equal to 5 and you will get the answer. Now, for the green region over here, since we are talking about the probability of Poisson, okay, and we know that Poisson, the event will be infinite event. So using the greater than or greater than x, it will be easier for us to use. And for this case, we are looking for px greater than 5. So using the third column, that will be equal to, go to directly to 5. Okay, so equal to 5, less than, greater than 5. So it would be 0.9329. And if you are using the CDF, now if you are using the CDF, okay, the total, you are talking about greater than 5, but 5 is not included. Okay, so it will be 1 minus probability of x less than or equal to 5. So it will be 1 minus less than or equal to 5. And you will get the answer the same as if you are using the third column. And for greater than or equal to 5, so I did a comment, put a comment over here. Px greater than or equal to 5 means that you are talking about Px greater than 4. So in this case, you are looking for x greater than 4. And if you are using the CDF, it will be 1 minus probability of x less than or equal to 4. You will get your Px greater than or equal to 5. So 1 minus Px less than or equal to 4. Now, this is how you can use your probability mass function as well as Poisson probability, where you are looking for the probability of x greater greater than certain value of x. And if you are using the CDF, so this is how you can use the CDF. And what about the interpretation of your answer? In this case, if you are talking about probability of x equal to 5, what does that mean? 0.0378. You can interpret this probability value as there is less than 4% chance that exactly 5 cars arrive in 15 minutes. Why 15 minutes? Because it is given in the dimension that is using the 15 minutes dimension. Now, Why less than 4%? Because if you multiply 0.0378 by 100, okay, so let's say take this value, multiply by 100, so you will get 3.783327. So you can say that this is less than 4%. Or if you want to use the probability value, exact probability value, so you can say there is 3.78% or there is 3.8% chance that exactly 5 cars arrive in 15 minutes. What about the answer for 0.9707? If you multiply by 100, you will get 97.07%. So in this case, since the probability value is almost 1, so you can just simply say it is highly likely that at least 5 cars arrive in 15 minutes. So this is how you can uh, interpret your probability value. Now, if you are looking at your distribution or bar chart of your number of occurrences in specified interval, so in this case, we are talking about the average is 10 in 15 minutes. So this is how the charts looks like from 0 until 10. So if you are changing the value of the mean, for example, into 8, so what happened? So it become this way. Why you stop at 10? Because I stop at 10 here. Okay, if you draw your region until maybe, for example, 15, so you will have 15 occurrences over here. So because due to this limitation, I put only until 10, so that's why the charts stop at 10. Okay, so if I go further and change the value of the lambda, for example, I change into 5, for example, what happened to the distribution? So it become a bit symmetric. And if I change even smaller value, so you will get skewed to the right. So what can you conclude from these particular charts? As you increase the lambda, it will be left skewed. As you decrease the lambda, it will be right skewed. And at certain point, your distribution, your charts will become symmetric. So that's how you can interpret from the given number of occurrences or number of success using the probability mass function, and you can have a look at the charts. And let me change back to 10, where the original problem that we have. And from this, if you are interpreting your measure of central tendency and measure of dispersion, so for the measure of central tendency, the mean is the lambda value, so it is equal to 10. The variance also taking the lambda value equal to 10, and the standard deviation is square root of the lambda, which is given by 3.1623. So what can interpret? So this is how you can interpret in terms of the value as well as the probability. Now let's move to the second questions. Okay, let's move to the second question. The second question is taken from your engineering statistics textbook on page 66, that is referring to exercise 2.4. The questions sounds like this. An average of 15 aircraft accidents occurs at each year. Find the mean number, variance, and standard deviation of aircraft accident per month. The probability of no accident during a month, the probability of exactly one accident during a month, and finally the probability of more than one accident during a month. So observe the question and observe the situation given. Now, the situation given is that you have 15 aircraft accidents each year, and the question asks for a month. So what can you do? So as usual, you begin with your definition of X. What is X in your case? X in this case is the number of aircraft accidents in a year. So this is the given in your scenario. Now, this X is distributed using Poisson. Why Poisson? Because we know that the occurrence is involving whether there is an accident or no accident. two outcomes, and it is given in a specified dimension, which is a year. So you can write down the distribution X following Poisson 15, and this one is in a year. Now, if you are talking about, since the question about 1 month in a month, so you have to change them into the specified dimension in a month. So if you can see, lambda for a year is 15. Lambda for in a month, how I can get 1.25? It is actually equal to 15 in a year. Since I'm looking for 1 month, so I divide by 12. And it will give you 1.25. So the first question is find the mean, variance, and standard deviation. So from here, the mean is I locate the lambda value from a month dimension. So it is 1.25. The variance also the lambda value 1.25, and the standard deviation is the square root of the variance, and it gives 1.1180. So what does 1.25 mean? So 1.25 means, in terms of the average value or the mean value, you can simply say there is an average of 1.25 accidents, aircraft accident in a month. Okay, means that more than one, but not really reaching two, but simply you can say that way. Now, as usual, okay, in order to answer your questions, we come up with three component or three column. The first column is for PMF, the second column is for CDF, and the third column is for the probability, Poisson probability, which is reflecting X greater than certain value of X. Okay, now let us generate the first column using the PMF. Okay, let me erase again the first column, and in this case I stop until 15. Okay, now why 15? Just a random value, a random selection. You can stop at 20, you can stop at 25. It's up to you. Okay, but in this case, I just stop at 15. So to generate the PMF, it will be equal to Poisson. Double click this, the first one, Poisson.dist, and then you have to put the input of the X value, that is beginning X, then with the X equal to 0, comma, the location of your mean or lambda, that using the a month duration, because the equation is using a month, and then comma, you are looking for the PMF, it should be false. So double click false, and then close the bracket, enter. So remember, if you drag down without specifying specific lambda value, so this will be, there will be some error. So in order to fix that, put the $sign to the location of your lambda, and then drag down until 15. So you will get that one. Now for CDF, okay, again as what you did in PMF, equal to Poisson, and then location of your X beginning with 0, lambda value in a month, comma, and then you are looking for cumulative distribution, so double click through. And log your location of lambda. And drag down until 15. So now you can see that you have reached 1 at 7. Okay, so means that the summation already equal to 1 when you have the 7th occurrence. Okay, now for greater than, so for greater than, so look at the comment here. If you are looking for px greater than 1, so you will use your px greater than 0 minus px equal to 1. So let me start with this. It will be equal to 1 minus the exact value of zero occurrence. Okay, you will get that. Then for the next one, it would be, okay, px greater than 0 minus px equal to 1. Okay, and then you can drag down because the pattern should be the same as you move on. So just drag down. Okay, you can see whenever you stop at 1, you get 1 as the cumulative probability. This one becomes 0. Okay, now let's move to our question that we need to answer. The first question has been answered. Okay, we move to the first, that will be, or the second question, the probability of no accident during a month. Okay, so no accident during a month, simply what? Equal to, using the PMF, equal to 0, so that will be the location. And if you are looking for CDF value, so it will be equal to less than or equal to 0. You will get the same answer. Now, for the next question, exactly one accident in a month. So exactly one, so it will be equal to, exactly equal to 1 using the PMF. You got the answer over here. Now you are using the CDF next. So it would be equal to 1. So it will be less than or equal to 1 minus less than or equal to 0. So less than or equal to 1 minus less than or equal to 0. So you will get the same answer. Now, since the next question refers to more than one accident in a month, so if you are using the PMF, it will be impossible for you because you don't know where to add on. Okay, so in this case, to simplify, you generate the third column, and using the third column, simply it will be where the location of 1. So that is the answer. Okay, so directly from the third column. And if you are using the CDF, so you are looking for greater than 1, but 1 is not included. So you are talking about 2 occurrences and up until certain value. So in this case, it will be equal to 1 minus less than or equal to 1. Okay, so you should get the same answer. So for number 3, okay, if you are using the third column, since the third column is referring to greater than x, okay, so if I'm looking for greater than or equal to x, it is simply equal to px greater than 3. Okay, so in this case, what? So just find the location of greater than or greater than 3. So equal to greater than 3. So you will get the answer. And if you are using the CDF, okay, it will be simply 1 minus greater than or equal to 4. Okay, so it will be 1 minus less than or equal to 3. Okay, so this is how you can get the answer, but because of due to the this to ease my discussion, I already put the answer so that it would be easy for me to rectify or recall the correct answer for each and every questions using the PMF and CDF. So how to interpret? Okay, if you are talking about no accident in a month, the probability is 0.2865. So you can say there is 29% chance that no accident occurred in a month. So that's how you can interpret the probability value. For example, in the next case is at least 4 accidents in a month. So you can say, simply say, it is almost impossible that at least 4 accidents occurred in a month. Okay, so in terms of the probability, the distribution of your charts, bar chart of your probability, since I am using until 15, and you can see you have the total probability 1 at the occurrence of 7. So you can see the effect of the effect of this particular charts to your representing the problem that you have in hand. So this is for lambda equal to 1.25. Let me change lambda into bigger value, for example, maybe 5. See what happened? The distribution become, a bit symmetric, but somewhat skewed to the right. Okay. Then, if you change into a bigger value, for example, maybe 8, what happened? Somewhat symmetric. Okay. And if you change into a bigger value, for example, maybe 10, it becoming a bit skewed to the left. So you can see the same what we call interpretation as what you did in the previous equation. As the lambda value increases, the distribution getting skewed to the left. Okay. As lambda decreases, the distribution getting skewed to the right. Okay. As you increase the lambda, it becomes skewed to the left. The same interpretation for the next equation. So in this case, let me change to the correct lambda value. So this is how you can use Excel in order for you to solve your Poisson probability distribution equation. So I hope the video is useful for you in order to understand the whole concept of Poisson probability distribution and how you can use some function in the Excel to solve them. Okay, that's all for this video. Thank you very much. In this video, I would like to share with you a discussion on the probability distribution of the Poisson random variable. So for this video, I will share with you two equations, and I would like to highlight that the equation that I'm using is the example 2.11 that is available on page 65. So what is the equation? Suppose that the average number of cars arriving in a 15 minutes period time is 10 cars. Find the probability that exactly 5 arrivals in 15 minutes. Now, this is the equation, very short, and you have to identify what is or what are the information given in the equations. So, knowing that this is a Poisson probability distribution, we are talking about the number of successes in a given space or a dimension. So, look at your equations and find where is the dimension and where is the information for the lambda. Okay, in this case, we can define X as the average number of cars arriving in 15 minutes. So this is the dimension within 15 minutes, and it is the success of the number of cars arrive in that particular given time. Now, what will be the given distribution of your X that following the Poisson? So we can write down as X following Poisson with the lambda value of 10. So we know that this 10 is given in 15 minutes. So you can put your information into lambda equal to 10 and the dimension is within 15 minutes. Okay, just to recall, in a Poisson process, the value of the random variable X takes from 0 to infinity. So what you have then, class, you have to remember, unlike binomial, okay, we know that we have specific number of trial. For example, in this case, last time in the last video, we have number of trial 10, and definitely we will stop at 10 success. Okay, 10 successes. So the difference between binomial and Poisson is that in Poisson, the trial will not stop. Okay, will not stop. It will continue until an infinite event. So in this case, you have to remember, you don't have to come up with the summation of the px because the probability continues until certain values. And for this example, I will just stop until 10. Okay, because we know that we are not going to have the summation of the probability, exact probability given into 1. So we'll just stop until 10 and we will continue how to solve this problem. So the problem you will have to find the probability that exactly 5 arrival in 15 minutes. So the question is given in terms of the given condition or the given space, that is 15 minutes. So in order for you to answer these questions, there will be three what we call column that you have to come up with. That will be the first probability mass function, as what we have done in the binomial probability distribution. And the second would be the cumulative distribution function, CDF, the same as what we did in binomial probability distribution, but in extra, since our condition of our event is infinite. So it would be helpful if you can come up with your third column, that will be the Poisson probability, and that reflect the probability of X greater than given number of success. Okay, for example, I give in this note that to find the probability of X greater than a certain number of success, for example, if you take one success, what is meant by X is greater than 1? So it is actually Px greater than or greater than 0 minus Px equal to 1. So you are taking the probability of greater than of the previous event. If you're talking about event 1, so you take the probability of the previous event, that is greater than 0, minus the probability of exact success equal to 1. Okay, so if you are talking about probability of X greater than 2, so how you can find the probability of X greater than 2? It will be probability of X greater than 1 minus probability of exact 2. So you can continue on until the last value of success, event of success that you are looking for. So let us begin with the probability of mass function, and we are talking specific success for 0 until 10. Why 10 is just, I just pick until 10 because our question is until 5 actually. You can stop at 5, but in this case, I just want to show you that we can stop at 10 number of success. Okay, how to find this value? Okay, as usual, we are looking for the PMF. So it will be an exact value of the for the exact value of X that we are looking for. So in this case, we are talking about by Poisson. So equal to, you can type poi, and suddenly it will pop out this Poisson.dist, and this is the one that we are using. So you double click this, and then it will come up with the instruction where you have to key in the X, mean, and cumulative. What is the X? The X is the number of success, which is this location. The mean is the lambda, and the cumulative, we are looking for exact value, so it will be false. So define or find the location of your X, comma, and then find the location of your mean or lambda, comma, and you are looking for mass function, so double click the false, and then you can close the bracket, or you can just enter. Now before you can drag down, remember, what you have to remember is that you have to fix the location of the mean or the lambda. So since you are using the same mean throughout your number of success, different number of successes, so you have to lock down the location of the mean. So you put the $sign in the location of the column, and then enter. See, I put $sign before A, $sign after K, and then you can look at the location of the cell in the red cell, so you can just press enter. So once you have did that, you can drag down until 10. Okay, so this is how you find the PMF. For CDF, it is almost the same, but we are looking for CDF, so it should be true. So in this case, I do it again. So equal to poi, and double click the poise.dist, and then define the location of your 0 number of success, which is the exact value of 0. the one that we are looking for, comma, the location of the mean, and then we are looking for CDF, which is true. So double click true, and then close the bracket and then enter. Again, log the location of our mean. So put $sign before A and after K, and then enter. Then only you can drag down. So just to show you that you don't have to find the summation of the PMX, PMF, like we did in binomial. If you add, you can get 1. But in this case, if you add, I just want to show you, when you add, you will never get 1 because you are talking about an infinite event. So it is continuous until certain value, and if you can have time, you can try what will be the value of the last event of X, the last success of this particular X equation. Okay, so in this case, let us continue how to find your third column, that will be the probability of Poisson, which is reflecting this particular probability of X greater than certain value of X that you are looking for. So for the first value here, okay, it will be equal to, okay, 1, because we are talking about the overall probability is 1, and we are beginning from the bigger value, greater than a value. So greater than certain X is, in this case, we are talking about 0 success. So 1 minus the exact value of your X. You will get 1. For the next one, it will be, okay, it will be the previous probability greater than 1, okay, minus the exact value of 1. Sorry, I would repeat again. The probability of greater than 1, probability of greater than 0 minus probability exact value of 1 success. So you will get the second one. So you can just drag down, okay, because we are doing the same process again and again. You just drag down until the 10th number. Okay, so that's how you can generate the third column for Px greater than X. Why does this third column is important? It is important when you need to find the answer for question that reflect greater than. For example, greater than 5, greater than or equal to 5. So the third column would be helpful if you are using the PMF probability. Okay. Now, what was the question? The question is only one, but I add up a few other questions just to show you how to find the rest of the answer using different types of questions, and how to you can use the PMF, CDF, as well as the third column in order to find the answer. Now, the question is exactly 5 arrival in 15 minutes. Okay, exactly 5. So if you are using the PMF, definitely it would be easy. You are referring to your exact success, which is equal to 5. And then you can just click the cell for exact value equal to 5. And then you will get the answer. So this is the PMF. Okay. And if